Wow, hello.
Yeah, hi.
Hi. So in next 15 minutes, we will give you an overview on the integration of the industry information hub as data integration layer with Senseye as cloud hub for predictive maintenance. Um, I can say that we are very proud to have released that integration pretty recently in October and managed to present you here. Rob, I think you want to start with the challenges we are addressing first together, right?
Exactly. We'll touch on the challenges and why we're doing what we're doing. So if we think about the world of manufacturing, there's a number of key challenges that we have to address in manufacturing organizations that we help with predictive maintenance. So one of those is trying to maintain the uptime of machines. We want machines that are running effectively and producing their products when they're intended to. But another key aspect is making sure that we do the more precise and correct type of maintenance. There's no point in over-maintaining machines unnecessarily, and you want to make the most efficient use of any maintenance skills that you have. And other aspects of that as well relate to, relate to the supporting remote workers in the remote environment. So we're a cloud-based application, and that's really key to be able to get support from experts across your business and across your field. And then also reducing those operating costs and the risks. So making sure the production manager and the maintenance manager are having the right data in front of them to ensure that they're operating effectively. And this all has a very positive impact on sustainability, making machines last longer, using less energy, consuming less spare parts. But a really important aspect in what we want to cover today is how do we actually scale the connectivity in those machines? So Ender, over to you, and we can touch on that.
Thank you. So the name of the challenge is the scalable data integration. It is a hard job, I can tell you. So gathering data from the automation field is a complex task that requires expertise in different domains, be it automation engineering, IT, and data science. Overcoming these challenges is vital for the facility if you want to harness the benefits of automation, optimize the operational efficiency, maintain the product quality, and utilize the predictive maintenance systems like Senseye effectively. So let me open up a little bit more what I mean with these challenges. One thing is handling data in diverse communication protocols. So that from different types of vendors and different types of devices, you have to manage all these diverse protocols. This is one thing. The second thing is data structures, so that you avoid data silos in your facility. The third thing I would say is pre-processing of the data, preparing it. And the fourth aspect I would mention as challenges, scalability, so that your system adapts itself quickly, that is the part, quickly to facilitate expansion from cell up to the cloud. So we have to address these challenges for our customers, and our answer as Siemens is the Industry Information Hub. So Industry Information Hub is an open ecosystem for agile and autonomous plants. It is integrated into your communication setup, and it can also work compatibly with the third-party systems. The central element of the Industry Information Hub is the integration layer. It's an integration system for all value-added applications shown on top of this picture. And overall, the Industry Information Hub is the one-stop solution for your data management. Let me explain you why. So, first aspect is it connects anything with everything. It may sound too bold or maybe too boring, but it is the truth for the IAH. I can assure you. You can collect brownfield data no matter it is third party, your own, or Siemens devices. You can pre-process data, transform and aggregate data. You can provide the data through well-known interfaces to everywhere. You can integrate this collected brownfield data in the form of time series data, historical data, and data model. And not only in a single IH instance itself, instead spread through your facility. That's also a key part. And we can also provide the data with the data model to inside SAP and as well as to third-party cloud systems. And apps running on top of the IAH, be it edge apps, inside SAP, or cloud apps like Senseye, they can make use of it. They can turn data into information eventually. So you can also enable standardization between IT and OT by the help of a semantic information model generated automatically by IAH. For this purpose, you can use any type of companion spec depending on your industry needs, as well as self-made data models. Then the fourth aspect I want to underline is one configurator for everything instead of having different ones for different purposes, be it connector configuration, data modeling, data processing, pre-processing, providing it to IT layers. You are doing everything in one configurator. That's a key value, or one of the key values. Then openness. Here I mean, if you want to adapt and extend the way you collect and utilize the data, then you can have your self-made edge apps as well as connectors by the help of a software development kit, an SDK that we are providing, and for free. And we are also providing Mendix sample apps as a low-code sample apps. Another aspect is scalability. It is given by distributing data and data model across IAH nodes from cell up to the cloud. And last but not least, Industry Information Hub is integrated with Siemens Accelerator, Industrial Operation X, and Total Integrated Automation. It's a part of that. Thereby, you can enable many more use cases by this seamless integration. So having said that, now we have seen how IAH makes shop floor data Senseye ready, Rob. Can you explain us some more insights on Senseye and explain us what are the benefits of Senseye?
Yeah, thanks very much. So yeah, it's really key, everything you've described here, because the key aspect of Senseye is actually building on top of condition monitoring data. It's a cloud-based application, and it's targeted at assisting in scaling the role of the reliability engineer. So the sort of person that's looking at condition monitoring data from machines and making decisions about when to intervene. But as we move into a digital world, and now we've got capabilities like IIH, where we're connecting thousands of machines. So it's not just about 10, 20 machines, it's capturing data from your entire factory. But what's really important is making sure you recognize that the user can become overwhelmed. So people can get fatigued with too many alerts and notifications. So we've got a layer of AI that applies machine learning into the solution that understands what the user's interested in and what's important on that day. And I like to think of examples where maybe we connect to 1,000 assets in a machine and we give the user one notification in the morning. The really important thing is the other 999, he's not had to worry about. He knows where he has to direct his attention. And this all leads to improved maintenance planning and improved outcomes where you can utilize the various resources within your workforce and result in better and more efficient planning. Well, maybe, Ender, we should talk about some of the outcomes and benefits that come to the users as well.
Yep.
So when we think about the value that we see from our customers, I've got some statistics here that just describe some aspects of this and what our customers experience. So we can see here a reduction in downtime by 50%. So if you've got production lines running, producing food products, cars, if you can actually get your downtime reduced and keep that throughput running through, and this is the type of statistics we get reported back to us. Also, the increase in the productivity in the maintenance team. Not having maintainers going out and doing checks just because they're worried about machines, actually focusing in and doing the right type of activity and value-added activity and making those maintenance teams much more effective in the type of work that they do. And then reducing the costs. Those costs that are within maintenance, it's not just the human costs, it's the cost of spare parts, it's the cost on logistics. And another aspect I think that's really nice with the discussion on the likes of IIH, people are putting in infrastructure and spending money on connectivity. But we're one of those use cases that builds on top of that. So you can actually add additional value to that investment that you've already put in. And then finally, when people think about sustainability, there's a natural tendency just to think of energy usage. But if you can extend the life of assets by 15%, you're not only saving money on CapEx, so your CFO is really happy, your other board members are happy too, because you're not impacting changing spare parts and changing machines out unnecessarily. But just to put this into context, there's a quote here from a very large global steel manufacturer that reflected back to us, and we've got some marketing material that's coming out soon on this. But the thing that I found really interesting here is that they say solutions like Senseye is actually a catalyst for change across their organization. So it's not purely about the technology, it's how that technology assists you in changing the way your organizations work and the whole culture within your organization. But Ender, maybe if we can touch on a little bit more how this all kind of fits together.
Yeah, let's go ahead. So then, beginning from the bottom, where the data arrives into the system. Industry Information Hub can collect data from any industrial device, as mentioned beforehand. So you create a data model so that you structure the data. And the key part is the upper layers, they know how to access the data and well-defined way to access the data. Then you can store the data on the respective industrial devices. You can pre-process it by the inbuilt advanced data operations capabilities of IIH, like calculating min, max, average, or any other additional aggregation options in a certain time range. Or you can transform the data by the help of a powerful expression engine. Then you can aggregate this data and data model across the IIH nodes spread through your facility. And at the end, you can provide this data to IT layer, to the apps like Senseye at the end. And the key part is in a condensed way, so that apps like Senseye do not get flooded with the shop floor data, so that they get it, so to speak, ready to digest, I can say.
Yeah.
So now, Rob, can you summarize what you are doing with all the data I sent to you?
Exactly, and that's great. And it really is the case that with a product like IIH that can do that capturing, we can actually get maybe what we want to think of as smart data, right? So it's data that's got lots of information, and this is what we want, information in the data that relates to the state and change of that machine. And from that, we build an understanding of what's the normal behavior for that machine. And this is all fully automated. When I say we, it's the product, it's the code that's in the back end. And once we understand that normal baseline, then we can start to identify if there's unusual behavior, various like spikes in torque parameters or vibration levels that are increasing, for example. And this is all indicative of a degradation somewhere in the machine that's unexplainable. We also combine that with input from the user and feedback, as well as bringing together maintenance information and maintenance records. So as well as our algorithms understanding the normal behavior from the machine, we actually model the user as well and understand what the user's interested in so that we can feed back into those models and those algorithms and have an improved outcome. Brilliant. So the more sensor data we see, the more user input we see, the stronger the output comes.